All right, we are good and we are on. Okay, now, I should say something for you, for the students that are watching this from Azerbaijan. I have hits from Azerbaijan. I'm wearing sunglasses because I forgot my prescription glasses. Well, these are prescription glasses. I forgot my normal glasses at home, so I'm wearing these. Okay? And plus they're like blue blockers, so I can see. They make things brighter. And according to Kamal, these are not sunglasses. I'm not quite sure what sunglasses are. You wear them to block the sun and the effects of the sun relative to glare. And that's what these do. So I'm not quite sure how these aren't sunglasses.
You told me they amplify the lights.
Well, yeah, but they get rid of the glare. They get rid of the glare. They block the blue rays. I don't know. I don't care. Okay. So what we're going to do is we're going to is this a little weird with the sunglasses on? Yeah. It looks less weird from this end, if you know what I mean. But anyway, what we're going to do is we're going to review for water and aqueous systems. Okay? Now, what I have right here in front of me is the test. Okay? So shall I read a little bit from the test? Is that okay? You all right with that? Okay, so you've got to know the following terms, okay? You got to know the following terms. Okay. Solvation, weak electrolyte. You got to know what an aqueous system is. You got to know what a solvent is. Electrolytes, colloid, and surfactant. Okay? Yes? Now, let me put in some more words in there. Dispersed phase. I haven't put an A in there, that shouldn't be in there. Dispersed phase, dispersion phase, surface tension. Do we have that already? Surface tension. Okay. We have Brownian motion. We have solutes. Solvents. Emulsion. Now remember, I don't do state capitals. So this is not just knowledge-based material. You have to know how these are going to be connected. Clear? So, would you like an extra credit? Okay, tomorrow for Wednesday. Is that right? Wednesday? Right. And that is that I want a mind map, which is a little bit different from a concept map. So what you'll have to do is you'd have to look that up. That's a technique that you should have learned way before 10th grade. Correct? How many people know how to do a mind map? Raise your hand. Okay, everybody? Yeah, you're a little bit sketchy, but what it is how things are connected. In other words, if I have a solvent electrolyte, how is that going to be connected with other things that are here? Clear? Now, for instance, what is the solvation process? What does that mean, solvation? These are terms. Diego, are you with me? Okay. Thank you for putting the cell phone away. I appreciate that. Okay. Appreciate your advanced support. Excellent. Okay. So what do we have? What is the solvation process? As a process, what is it? Yes? Well, I'm calling on you. I can do that.
Solvation is dissolving something.
Dissolving something, but how? What does that mean? Well, if you think of this, this is not an equation, this is more of an analogy, okay? You know what the micelle is, right? The micelle, in terms of colloids, the stabilization of an emulsion, when it stabilizes, if I take oil and water, correct? Yes? What I do is I break the oil down into little droplets. Now, each individual droplet of oil would be, let's say, between 1 micron and 1 nanometer, correct? 1 micron is 1,000 nanometers. I think the book says that a colloid is between 1 nanometer and 1,000 nanometers, correct? Well, 1,000 nanometers is a micron, right? Micrometer. Correct? Now, let's blow up, it would be difficult to work in the micron range, right? So let's not do that. So let's make a giant bubble, correct? And a bubble of oil, that's oil, correct? And what I'll do is, I'll put in soap molecules, okay? Now this part of the molecule is organic, correct? That's the CH3, that's the hydrocarbon end. The hydrocarbon end of a soap molecule is nonpolar, correct? Now, something in chemistry called, you know how I hate rules of thumb, right? But this is one of the rules of thumb that I embrace, especially for young chemistry students. But it is going to be like dissolves like, correct? Polar solvents dissolve polar solutes, and nonpolar dissolves nonpolar, correct? So even though this is part of a colloid, this is a micelle, correct? Even though we're making a micelle here, even though it's a micelle, and when I say like dissolves like, and the word dissolves usually refers to what? Solution, colloid, or suspension? Solution, right? But we're using the word dissolve here because it's actually dissolving. In other words, I'm taking the nonpolar side of the soap and dissolving it in the nonpolar oil. And what's left on the outside is this charged ionic side of the soap. Clear? What's the problem, guys?
I realized I left my computer in here.
Okay, that's not a problem. Hey, we have a random guest who left their computer here. Excellent. You may leave random. No, go this way. Go this way, honey. You know what? I'm filming. You don't want to be on candid camera, do you? Have a nice day. So, this ionic charge is going to hook up with the positive end of the water molecule. Do you see that? And that's going to kind of hang out. Yes? So this, okay, put one in there. So the partially positive hydrogen, Dennis, thank you for paying attention. I appreciate that. You're doing very well. Excellent. I appreciate your advanced support. That positive partial charge of hydrogen is going to be attracted to the ionic end of the soap molecule, creating a micelle. Yes? Well, if you think of the micelle, solvation is not terribly different. This is where I'm kind of like talking about the solvation process. I'm not losing my mind and going off on a tangent. In other words, if I take sodium, okay, sodium is surrounded like this. This is water. Okay? So it surrounds it. So the water molecule actually solvates. Solvates. So the chlorine is going to be like this. Okay? Where the hydrogen, the partial charge of the hydrogen is going to be solvating the chlorine, and the partial negative of the water will be solvating the sodium. Correct? Are you with me? That's really what solvation process is. Yes, Massa? You just, okay, understood. Anyone else with that? Yes? Anybody understand what aqueous is, and how does aqueous fit in here? Aqueous is like from Latin. Why don't you look up the word water in Latin? No, yeah, agua is Spanish. I know that. Thank you very much. Yeah, and what are we doing? Are we playing a game, Nabil, on that? Because you look like you're kind of shaking it around like this, like you're trying to, you know. It's just your screen is messed up. Excellent. I like the fact that you're using a messed up device to help you with the review. You've been doing that for the last 15 minutes. It's really good to know that you're on the edge of your seat here with the review. Excellent. Anybody look it up in Latin? What do you got for Latin for water?
It says aqua, but there are also other words like latex is for any liquids.
What do you got, Dennis? I can't see the phone.
It's net or something like that.
All right, so maybe it's not exactly aqueous. Anyway, it's certainly Romance, kind of Roman, Greek probably, whatever. But this simply means water. An aqueous solution is a water-based solution. Yes. So most of the solutions we use as a young chemistry student are going to be aqueous solutions. Rarely in a high school are you going to make a solution where you have benzene or acetone or something severely organic. Yes, Mohammed.
So an aqueous solution is a solution that's solvent in water.
Yes, the aqueous solution is very, very specifically where the solvent is water. Where the solvent is water. And the solute, in order for water to work as a solvent, this is key. You have to have some kind of hydrogen bonding, you have to have some kind of dissociation, but not all substances that dissolve dissociate, such as sodium and chlorine. Sucrose, glucose, they will not dissociate, but how do they dissolve? Massive hydrogen bonding. Yes? If you look at the molecule, which maybe I'll put on the next slide, like I'll make the non-cyclic form. Maybe I'll put the cyclic